So as far as on tangent, I think, yeah, we can just go and graph these. That's fine. Again, I'm just going to graph the initial period because, again, all you would do to do more than one period is you just keep on adding those x scales. So that's why it's very helpful to find the x scale, which is whatever the period is divided by 4. Now, as far as for tangent, I don't do the period divided by 4 for the x scale. I do the period divided by 2 because when you look at the tangent function, there's only two important points. There's the asymptotes and the x-intercept, and that's it. So let's go ahead and take a look at this one. So here, my period is, so now, and again, this one's kind of weird too, for when I'm doing this for tangent. Now again, remember the period is pi divided by 1/2. So that's equal to 2 pi. So again, remember tangent has a period of pi. So if the period went from pi to 2 pi, you can see that obviously the graph is horizontally being stretched. As far as my x scale goes, what I like to do here is I just take whatever my period is, 2 pi, and I divide it by 2. So therefore that one equals pi. Now as far as the start and the end go, if you remember the initial period for tangent, which I'm not sure why I didn't do, here, I'm not going to graph this one, but let's just do y equals tangent of x. Remember the initial period looks like this. Which is at pi halves and negative pi halves. So the start of the initial period is going to be whatever's inside your function equal to negative pi halves. And the end inside your function is going to be whatever's inside your function equal to positive pi halves. And then just go and solve for x. And so in this case, we get negative pi, and x is equal to pi when you multiply by 2 on both sides. So when I go ahead and graph this, I'm at negative pi and pi. And do my nice little asymptotes here. Bad asymptotes. But you can see that, yeah, the period's going to be 2 pi, which we already kind of knew. And then I'm just going to do a really bad S-curve because it intersects there at 0. There's nothing been shifted up or down. The only thing that did change, though, is the graph was shifted down 2 units, right? So actually, my graph is going to look something like that. So let's actually erase that one. Okay, but again, like you can see how that start and the end kind of help us as far as the graphing goes. And the x scale would really only help you as far as if you needed to do like 2 periods. Like typically that would we ask on a test would be like do 2 periods. So then you just know your x scale is just going to be adding pi. So the next intercept is going to be at 2 pi. The next asymptote would be at 3 pi because you just keep on adding pi's. The important thing to remember from tangent, at least some common mistakes here, is remember tangent doesn't have an amplitude. There is no max and min, right? This is infinitely rising, rising without bounds, up and down. So therefore, as far as the tangent goes, this 2 is just going to be a vertical stretch. So it's actually not going to be impacting the graph at all. Now, as far as understanding the transformation, I told my students the best thing that we want to do is be able to factor out that b. When you factor out the b, remember thinking of factoring is like dividing out the 3. And think about dividing by 3 is the same thing as multiplying by 1/3. What would happen if you multiply both these terms by 1/3? You would get x plus pi over 3. And again, you can always check your work. 3 times x is 3x. 3 times pi over 3 is just pi. But my preference when you need to graph this is let's go and find the period in the x scale. So the period is going to be pi divided by 3. That's your b, which is nothing really you can do. The x scale, if you need to do more than one period, I just like to do my period divided by 2, multiply by 1/2. That's going to be pi over 6. So then my start, this is a lot to work with, is going to be 3x plus pi equals negative pi halves. And then my end is 3x plus pi equals positive pi halves. All right, so if I add pi, that's going to give me a positive pi halves, and I divide by 3, that's going to give me negative pi over 6. So you guys can do your work to verify. Here, if I add pi, that's going to give me a 3 pi over 2, and if I divide by 3, that would give me a 3 pi over 6, which would give me a pi halves, which I'm, no, wait, I'm subtracting. That's right. positive pi's. Yeah, if you subtract this, it's going to give you negative pi halves. Wait a minute, what happened here? That's a negative pi, that's a positive pi. 3x plus pi. Oh, I did that wrong. My bad. All right, fine, I'll just do the work. So you subtract pi on both sides. That's a negative 2 over 2, negative 2 pi over 2, negative 2 pi over 2. So I get a 3x equals a negative 3 pi over 2. Multiply by 1/3, if you want to think about it like that. Right? Multiply everything by 1/3, so I get x equals, this would give me a negative 3 pi over 6, which can be reduced down to negative pi halves. There we go. So here, I'm going to subtract a pi. That would give me 3x equals a negative pi halves. Again, multiply by that 1/3. X equals, what was my scale? X equals 2 pi, 3 pi. X equals a, oh, because it's getting shifted, pi over 3. That's going to be multiplied by 1/3. That's going to be negative pi over 6. So I got enough room for this one? Barely. All right, so we're at a negative pi halves. And you know what? Let's forget about this. Now again, that's negative pi halves, but if you want to think about that in terms of your x scale, think about that in terms of, well, actually, you know what? I'm just going to, and this would be a negative pi over 6 as far as my endpoint. So that's where my two asymptotes occur. Now, the question is though, like, where is this x-intercept? Well, again, like this is your x scale, right? So that's the nice thing why I do it by 2 is like, here is an important point, here's another important point, there's another important point. So my x scale is pi over 6. So if I just take negative pi halves and add my next x scale, pi over 6, that's going to give me this coordinate point, which is, again, it's like, I think in my point, it's like too much work really for the purpose of it. Plus pi over 6. That's going to give me a negative 2 pi over 6, which is equal to negative pi over 3. There you go. And that would make sense. And then if you add a, so negative 2 pi over 3, I hope my math is right. Because then if I added another pi over 6, is that supposed to be negative 1/2? Add another pi over 6. Now this problem is taken to the, add another pi over 6. That's going to be a negative 2 pi over 6 plus pi over 6. Yeah, which is a negative pi over 6. Okay, so I'm working good. So anyways, that's going to be your answer. Obviously, your y-intercept there. And then you could just keep on adding pi over 6 to get to your other points. All right, I'm not going to graph this one. The only thing I want to make sure that you understand is, again, to make sure that you rewrite this tangent of negative x plus pi halves, and just make sure you factor out that b. Nobody asked me for this equation. I just made it up. But the important point here, guys, is making sure that you guys factor out that negative.